Well, welcome everybody to the British Astronomical Association Hydrogen Line group meeting on tonight, Monday the 4th of May 2026. It's wonderful to see so many of you here, and while we were waiting to get started, to start hearing about some of the projects and various things that you're doing in all sorts of different aspects of radio astronomy. So I'm certainly looking forward to hearing more. At the moment, our speaker for this evening hasn't yet turned up, but no problems. Speaker or no, we run these meetings a bit like Sarah does with its Drake's Lounges, and go through everybody one at a time and give everybody a chance to talk about what they're doing projects-wise. And just before we started, I'm going to, if Andrew doesn't mind, I'm just going to pick on him a little bit. He was talking a bit about some coincident interferometry that he was trying to do. And would you mind if I asked you again, Andrew, to tell us again what that involves and how far you've got with it?
Yeah, so basically it's two monopoles in a single waveguide. It's a circular waveguide. There are 90 monopoles are at 90 degrees angled to each other, which you could use for phase monitoring, but with hydrogen line, the signals are so randomized there isn't any phase that you can actually monitor. So what I intend doing is putting the two individual monopoles into an amplifier and then into an SDR into a computer, and then using interferometry, either multiplying or adding, in order to try and improve the signal to noise from the antenna that I've got. And so at the moment what I'm trying to do is I've got 6 different amplifiers, and so I'm running through those one each night, measuring the response I get from each of them so I can get a matched pair, which I can then put onto the sort of system to do the interferometry. And I've also had to upgrade the PC because the best responses I'm getting are with AirSpy Minis in terms of the signal sensitivity, but with 2 AirSpy Minis running at 10 megabits per second sample rate, a standard mini PC just struggles to keep operating. So I've had to upgrade one to more cores and more threads in the hope that that will allow 2 AirSpy Minis to work simultaneously over a long period of time.
I feel there was an awful lot in there. Do you mind if perhaps I ask you a little bit more about it, just
Sure.
to help to dissipate it a little bit? Because I'm aware that some people are quite new to this, and in fact this whole business of interferometry is often, for most of us, is something that we don't do much of or any of at all. And in addition, we get people watching these videos who have never done any radio astronomy before at all, so it's worth going back over some of the basic principles as well. So I guess when you talk about interferometry here, you're not talking about interferometry in the way that most people think of it, where you take 2 signals and generate an image that is has a resolution the same as the distance between 2 antennae, are you? Because you're talking about 2 monopoles on the same waveguide, the same bit that collects the data.
Yeah, the principle's the same. It's just you haven't got the separation between the monopoles, so the sort of phase angle is 0. And so, but in terms of the sort of processing side, if you do interferometry with GNU radio, you can separate the magnitude and the phase out. Well, there's no point in doing that when they're both coincident. Mm-hmm. So it's just simply then multiplying the 2 together or adding them together and seeing if that improves the signal to noise.
So you're literally adding up the 2 signal sort of total levels, power levels or whatever together, or you're multiplying those 2 levels together. Is that what you're saying?
Yeah.
Yeah. And what's is there an advantage to using addition or multiplication over the other one? Don't worry if you don't know the answer. I'm not trying to put you on on the spot here. I just was interested.
that's part of the experimentation. In terms of when I've done it with interferometry, if you do multiplication, you do get much larger signals. But that was doing interferometry on the sun. On this process, I'm not sure whether the adding might be more calmer than multiplication, because multiplication, if you multiply everything, you get bigger numbers all the way around. But this is part of the experimentation I do. I'm an experimentalist rather than a theoretician.
Yeah. So if I understand correctly, what you're talking about here, so is it a dish that you're using to collect the data?
Yes.
Yes. So you use a dish to collect the data, and then that directs all the signals to the focal point of the dish, where you have your waveguide that then sort of funnels those signals down to what is essentially the antenna bit that's actually going to collect the data, which in essence always seems to boil down, it seems to me, to either effectively a monopole or a dipole at the centre of everything. I mean, that may be an oversimplification on my behalf, but most things seem to end up that way. And so you've got a monopole, which is just a single piece of wire, effectively, which is tuned, i.e. its length is a fraction of a wavelength of the hydrogen line, and that sort of then resonates at the correct frequency, i.e. in this case the frequency of hydrogen at 1420 megahertz, and then turns that into an electrical signal, which can be funneled through your filter into your software-defined radio and into your computer. But you're using two of those, which are at right angles to each other, to try and get more data. Have I got that correct in my description there?
Yeah, so basically, sort of, instead of having one antenna, I'm trying to have two antennae, but in the same rig, and then using those two to join the signal or join the data together in order to hopefully improve signal noise. Right.
And what was the advantage of having those two monopoles at right angles to each other?
Just convenience for mounting them.
Okay, I've got a question here on the chat from Richard. He said, "What about squaring the numbers?" Richard, what do you mean by squaring the numbers? I think Richard has problems with his microphone, remember from previously. Perhaps I'll tell you what, we'll carry on speaking. Maybe, Richard, you could just put that into the chat, what you mean by squaring the numbers, so then I can ask Andrew that. Ted, has something you want to say as well? You can just say something. Oh no.
I say, would a mixer be an easier way of approaching this? I'm thinking of like what happens on audio desks is when you've got two microphones, you can mix them together in different ways. I mean, in some cases, you might get a better signal to noise by subtracting one from the other rather than adding them. But you are blending them, so if you trying to think how you would mix them, because you'd want a software-controlled amplifier on each of the for the preamps.
Is that something, Andrew, that you think would be helpful at all?
I have absolutely no idea. I'm just basing it on, I have played around with GNU radio interferometry based on the West Virginia University Despera stuff, and that was using two 750mm cylindrical feed horns with different distances apart on an east-west axis, and just looking at the sun. So as the sun goes over the head, you can monitor it. And so I'm just looking at the same layout, if you like, of the GNU radio software, but having the two feeds coincident rather than meters apart.
Yeah.
And it's just an experiment to see whether it will give any benefit or not.
I know it's something that I tried myself in the past, I'm really interested to see how well it works for you, because I tried it with a cantenna with two orthogonal, that's 90-degree monopoles from each other, and what I discovered is the signal on each monopole went down, which meant when I added them together I didn't do much better than with one alone, and I have absolutely no idea why that occurred. I really do not know. But my understanding is that, again, please correct me if I've got this wrong, Andrew. So with some signals you get polarization of those signals, so they may have a different strength depending on the direction that your aerial is or your antenna is facing. But with hydrogen this isn't the case. It's completely randomized, so you can't pick up a difference in polarization signal. So whether you put your monopole facing east-west or whether you put it facing north-south would make, if you had just one monopole, shouldn't make any difference at all to the strength of the signal that you picked up. If you had a signal from something where it did matter, then if you let's say for example you had one where you had a very strongly polarized signal, then you might put a monopole facing east-west and get a nice strong signal, then put it north-south and get no signal at all in its extreme. But with hydrogen, technically you shouldn't get this, so you should get the same in both directions. So in theory, at 90 degrees to each other, they shouldn't interfere with each other, so therefore you can pick up theoretically two completely separate signals, and then as you're doing, combine them together and get a stronger signal to noise ratio as the result of it, almost like having a bigger dish. At least that was the theory. Unfortunately, it wasn't the theory that worked when I tried to do it. But of course, there are all sorts of reasons why that might be. It might be just probably a completely incompetent radio astronomer being the most likely one, or rubbish kit. Who knows?
Yeah, maybe that putting another piece of metal in there, you reduce the signal. I mean, just like you're extracting the radio wave inside the cantenna. I mean, what would be a purpose of it? I was going to say the radio interference could well be polarized. All radio signals are polarized. Radio frequency interference might not be, because it may be from all sorts of things like electronic devices somewhere. But that would be the advantage, and the real advantage of mixing two feeds would be you don't have to go outside and twist the whole cantenna around to get the best signal to noise ratio.
Yeah, I mean, I have done some experiments with just a 750mm feed horn feeding into the waveguide with the two monopoles. I've done some testing in a shed, and I found that you could get signals on both of them, but the signal on one was weaker than the signal on the other. And that's why I'm going through testing my various amplifiers, trying to get matched amplifiers, because I'm pretty sure that the weaker signal is due to the amplifier itself.
You didn't try turning your waveguide by 90 degrees and see whether the effect twisted with it?
No.
Okay.
Yeah, it might be worth it, trying that. The other thing is perhaps you should have two antennas.
2 4-meter dishes, yeah. I'm not sure that the observatory will go for that.
Okay. Yeah, that's asking a lot.
Yeah. But,
I mean, I have been playing around with how to mount the new waveguide onto the dish. What I've gone to the length of is sticking some small sort of 1-inch square mirror segments on the dish parabola, and then point it at the sun in order to see where the focal point is. And so I'm using that method to try and tune in the waveguide positioning.
Yeah, I've heard that before. Does it work well for you?
Yeah.
Excellent. I mean, where did you find the sun?
It's been around the last, week or so. It's gone now.
Well, we went to Crete, and the sun came out here while we were in Crete, and it was raining in Crete, and then we came back here, and the sun went away again. So I'm not convinced you guys had any sun. I think my children were just lying to me when they spoke to us on the phone.
It's all your fault then.
Yes, thanks. Go away again, Andrew.
So you mentioned there about testing. I mean, perhaps more relevant generally to hydrogen line stuff rather than interferometry here. You talked about testing the response of the filters. So to remind people who are new to this, either people on this group or people perhaps watching this for the first time, or maybe not done any hydrogen line work. So the normal setup for a hydrogen line radio astronomy or telescope is that you start off with some form of antenna. It doesn't have to be a dish. There are other types of antennas that you can use, such as a Yagi. It's been very successful use for this, which is like a TV aerial. So you have some sort of antenna if you're over in America, or aerial if you're over here in Europe. And then very close to the feed of that, you usually have a filter of some scripture and an amplifier. And then that goes down some coaxial cable, which goes down to wherever your computing device is, and then you have a radio, and we tend to use these days things called software-defined radios or SDRs. So that's the normal setup. And Andrew there mentioned a number of things about those, and one of the things you were mentioning was testing the response of the filter and the low noise amplifier. So what sort of setup are you using to test these devices to see what their performance is like?
So basically I've got a waveguide in the bottom of a 750mm conical feed horn.
Mm-hmm.
So the top open aperture is 750mm, and that is sitting on the ground inside my roll-off roof observatory at the bottom of the garden here, and pointing sort of vertically upwards because I don't want to add various angle interference if I can't get the same position of azimuth and altitude. Then I will be introducing errors. So pointing it directly upwards seems the simplest way. And then just connect the monopole from the waveguide as close. So I'm using I think it's a 100mm SMA cable to the amplifier. Mm-hmm. And then from the amplifier, I'm using a power injector to introduce the power to the amplifier, and then that is then cabled by probably a meter cable to the receiver, the SDR. Mm-hmm. And in my case, I'm using AirSpy Minis, and then that goes into a mini computer, and I just leave it running like that for 24 hours, and every 24 hours I swap the amplifier for a different one, and then just compare the responses that you get in the process traces.
So I would guess the idea is that the waveguide, effectively the antenna at the end that you're pointing at the sky, the coax, the SDR, the computer, they all remain exactly the same, and you just keep swapping out the filters, and you do them as quickly as possible after each other, so there isn't too much change in the sky or any other part of the Milky Way that might be passing overhead. And then you just check the signals.
Well, I'm doing it over a drift scan of 24 hours, so I'm making the assumption that cloud cover and things like that won't have a major difference in the. They do have some impact, but not a major difference in the responses that I'm receiving.
Yeah, I mean, I was just thinking if you did it 3 months later, you might have a little bit of a different part of the Milky Way might pass through the zenith. So mind you, it's a waveguide like that is going to have a very wide field of view. So it's about 60 degrees probably. So it's going to pick up a lot of sky. Yeah. Okay, brilliant. Yeah. Well, thank you very much. The other one was, if you don't mind me asking you, was that you were mentioning a number of times using the AirSpy Mini. And which I bought one recently. I have a funny feeling it's in this box. I forget what I bought it for. I bought it for a specific reason, and I can't remember for the life of me what that specific reason was now. And anyway, so I think you and I have spoken about this before, and you've talked about the advantages of the AirSpy Mini. There's a number of those. I mean, and just before we started this meeting, we were having a little bit of a discussion, or started on that discussion. I think it was Conrad. Forgive me if it wasn't you, Conrad. Mentioned it because most of my stuff at the moment is running on RTL SDR blog devices, and I've got to say I've very successfully mapped the Milky Way using those. But what is the potential benefit of an AirSpy over the RTL? And I must mention, for the sake of the video and for the sake of the BAA, that none of us here, as far as I know, and certainly not me, have any financial interest or other interest in any of the companies that produce any of this kit. You don't, do you, Andrew? No. it's just personal experience that we're talking about here. So, in your personal experience, what do you feel is the advantage of the AirSpy Mini over other types of SDRs, if there is any?
Well, I mean, the RTL SDRs have a 2.4 or 2.5 megahertz bandwidth. Mm-hmm. So the amount of frequency range that you're observing is fairly narrow. But they do. I have no comparison of the A to D, the analog to digital converter resolution of the RTL SDRs compared to the AirSpy Mini. I think the AirSpy Mini is a 12-bit, but the advantage with the AirSpy Mini is you've got a faster sample rate because you can go up to 10 megabits per second, and obviously you get 10 megabits per second or 10 megahertz window that you can look across, and it is my belief that as you improve the bandwidth that you're looking at, you will also improve signal to noise. But I just find that the AirSpy Minis tend to be much more sensitive. If you think about what I'm doing, I've got a feed horn in a shed with a roof on it, and I'm looking at the hydrogen line or hydrogen signals through that roof up into the sky. And so I am fighting for signal to noise. And so this is a good test for the instrumentation. And I just find that the AirSpy Minis are better at receiving that signal than the RTL SDRs.
Right. Okay. Well, I feel as though I've dominated the questioning here. I deeply apologise to everybody else. Please, Ted, anybody else, anything else you'd like to ask or mention? No. Oh, Conrad's. What would you like to say, Conrad?
Can you unmute yourself?
Yeah. So at the top, you've got leave, share, microphone. Usually there's a line through the microphone.
Okay,
Yeah,
now I'm
brilliant.
ready.
Well done.
We kind of initiated this meeting to talk about meteors, and I'm hoping everybody else is as interested as I am in it. What I find interesting, because I've been doing this maybe about 4 or 5 months, is I get readings and I'm never sure if they're really right. If you let me, I'd like to share my screen and some things that I have, which might be of interest to other people
Sorry, Conrad. My apologies. Are you talking about meteors here?
Yes.
Yeah. So you have to forgive me. The meteor meeting is on the 29th of June.
29th of June. Oh, I missed that.
but don't
okay.
Look.
I'll tell you, this is what Andrew's talking about.
No, but sorry. Just please forgive me a second. In spite of that, don't worry. We're talking about this is a hydrogen line meeting, but it matters not. So for the moment, we'll talk about hydrogen line.
For sure.
But when we've gone through everybody, I will come back to you. And I know that most of us here will still be very interested in what you have to say about meteors. And many of us
Okay.
here, including myself, do meteor observing. So when we get towards the end, I will come back on the meteor question for you and give you a chance to talk about that as well.
Okay, thank you.
But if you'd like to, at the moment,
I don't know how I got the dates all mixed
It does-
up,
it-
but
it
thank
does-
you for pointing that out.
it doesn't matter. The 29th of June is actually our first meteor meeting. We haven't as yet had one, so easily to make that mistake. Don't worry about it, and don't apologise. But at the moment, have you got
Okay.
anything that you would like to talk to Andrew about? Anything that he's discussed at the moment?
I think it's real. I don't have any questions to ask him, but what he's doing is what I've been thinking about, possibly putting multiple antennas together just to observe the Milky Way hydrogen line. I'm very curious how he does it because, I've only been doing the hydrogen line for maybe 4 months. And, this is what I call like the first stage of it. But I do have the scope in the box. But once I get beyond this, I would, I've been thinking because you see it all over the world where they have multiple antennas connected together to increase their signal to noise ratio, and they get great results with it. So I'm going to mute my mic because I'm very interested in what Andrew has to say.
No. Please carry on. So you say you've been using scope in the box for the last 4 months, and how far have you got with that project?
I have completed just using the scope in the box. I did do one sweep of the sky, and the results did come out very well. But now, using a suggestion from Alex Pettit, I put some screening around it, which hopefully is going to reduce some of the noise and may just increase my signal. In fact, I'm using Ezra, and I'm just going to share a little bit of my screen with you.
Yeah, absolutely. Please do. Show us what you got.
Okay.
While you're finding that, I'm just going to remind anybody who doesn't know that Scope in the Box is a project which you can find out more about on the Society of Amateur Radio Astronomers website, which I think is radio-astronomy.org, I believe, which is the American amateur group. And in their shop, you can see a link to that. And it's an excellent project with an absolutely brilliant instruction manual, which enables pretty much anybody to get started in hydrogen line radio astronomy, which is radio astronomy of our Milky Way, because it's composed mostly of hydrogen.
I am sharing the screen because right now I'm taking data.
Very good.
I have my antenna with the Alex Pettit suggestion with the wire screening around it. I want to repeat all of my measurements. I've got my antenna pointed along the north-south line, and right now I have it pointed at 35 degrees. And some other pieces of information, the frequency bin, I'm gathering 512, and it takes about 27 to 30 seconds to grab some data for the file. I found Ezra very easy to use, and I really like the results from it.
So before you continue there, let's just ask a couple of questions. So this is Easy Radio Astronomy, which is a software suite produced by Ted Klein, and is available off GitHub for anybody that would like to download it. A free set of Python scripts, which does an absolutely brilliant job in terms of radio astronomy. In fact, it's revolutionised hydrogen line radio astronomy and changed it from an amateur project where the difficulty was collecting the data and then finding out how to analyse it. Now you collect your data, press a button, and 250 plots come out, and the difficulty is trying to work out what any of them mean. So it's completely revolutionised the issue. Works on Linux and Windows, I would point out. The so you what? So that's sorry, easy range astronomy. So what SDR are you using? Are you using the RTL SDR as recommended in Scope in the Box?
Yes, that I'm using that one. I'm using the Sawbird
Yeah.
for the hydrogen line to amplify it.
Yes. So the Sawbird. Sorry, forgive me again for anybody who doesn't know what it is. So it's a firm called Newelec, which is a Canadian firm, and it's called the Sawbird H1, and that is a combined amplifier and filter. And again, so your SDR is costing you around about $40-50, or £40-50, and your Sawbird is also costing you about the same price. So overall, you're only spending about $100 or about £100 plus your antenna. So it's quite a cheap project to get started in these days. And what sort of computer are you using to run your software on here?
I have a little mini computer. I have an observatory outside,
Mm-hmm.
and there's a mini PC outside. It has an Intel i5 chip in it.
Yep.
And from there, I've got a USB cable going to the RTL SDR.
Mm-hmm.
Okay, and then via Wi-Fi, it sends a signal because I'm in my office and I can monitor the signal all day long, see how it's doing, and so I never have to go outside. And I'll have this run for several days. Probably tomorrow I'll change it to a different angle. We finally have some good weather here where I can do this. And, it does take several weeks to get enough data to get somewhat of a picture when you analyze it with the Ezra software. The Ezra software is working very quickly, and all of this processing I'm going to repeat again during the summer, but I'll probably use a higher frequency bin and compare the two to see if there's any improvement in the image.
So can you point out onto us where the hydrogen signal is on that picture?
Okay, for everybody who's here, this is an Ezra. If you notice with this very nice graph that we have, which is relative power as a function of the frequency, you see right along this hydrogen line, which is 1420 megahertz, that I've got this spike. Now, it's not exactly on the line because there's going to be a Doppler shift because all of this gas in the Milky Way is moving. Now, one thing I've noticed, in a couple of hours, there's actually going to be two humps in here that are very easy to see. One hump coming from the center of the galaxy and another hump from one of the arms of the galaxy. And, there's a set of videos that Ted Klein has produced that were really very, very important and very helpful in getting started. But once you view those videos several times, then you'll find that setting it up and using it becomes much easier. And that's all I have to say right now.
You mentioned the frequency bin quantity there of 512. What does that do, and what potentially might changing that do to help, do you think?
Let me see. Let me try, because I missed a part of your question. Could you repeat it again, please?
Sorry, forgive me. You mentioned changing frequency bin quantity from 512.
Okay.
I just wondered what that did and what changing it might give you potential benefits.
What this frequency bin deals with, there are 3 settings that you can use with the RTL SDR. The first one is 256. This one is 512. Along this horizontal direction, with this setting is going to cut it up into 512 channels. And it's gathering data, it's averaging out, it saves it to a text file. This way I've got it set to 512 channels to get a finer resolution on it. During the summer, I'm going to set it up to 1024. So hopefully I will get finer resolution and maybe a better image after I've collected all of my data at all of the angles possible.
Right, oh, brilliant. And the other thing I noticed at the top of the screen is you've got this frequency center ref. What does that do?
Yes. Okay, this is very interesting. In optical astronomy, because I did a lot of that for decades before I do this, one thing you always have to take when you're imaging at night, taking pictures of, maybe a galaxy or something, you take an image of the galaxy, and then you're going to take a dark frame, okay, which helps you with identifying noise in your image, okay, and you're going to subtract that in order to get a cleaner image. So this reference frequency of 1423, okay, this Ezra software will first take an image or gather data at this frequency, and then the next time it takes data, okay, it's going to take it at this frequency, 1423, because there's no hydrogen line in there. And the advantage of that is it's going to take the 1420 frequency and subtract this 1423, which has no hydrogen line in it. So you can remove some of this background radiation in your data, and then it'll store it. You still get some noise. The scope in the box is a very handy tool to learn with, but it has a very wide field of view, so it will gather some noise from other sources. Let's see, what else can I suggest to point out here? You can see what my latitude and longitude is. I've got it set along the north-south line, and I do have this antenna set at 35 degrees. Andy, it sounded like you were going to ask another question.
Sorry, it wasn't me, it was somebody else. Who was that?
It was probably me. I was going to make a comment based on your discussion of the number of bins to take before doing the Fourier transform. I've been comparing a number of different software programs, and one thing I noticed is that if when you take higher bins, a larger number of bins, once you do the Fourier transform, you're going to have effectively higher resolution. What I found was actually really helpful was taking the largest number of bins possible, not so much to improve the resolution of the hydrogen line, but to get rid of stray RF interference. So at least in my environment, I have some radio interference from, I think, nearby cell phone towers, and those show up as really narrow spikes, a very well-defined frequency. And even if I take 4,096 bins, those that interference is only 1 pixel wide. And so doing something just like a very simple median filter after the data can very effectively get rid of that interference without affecting the shape of your actual data, because you've got, your real hydrogens are, much wider than that.
That's interesting. I'm writing this down, and I want to look into Ezra to see how I can adjust any type of median filtering. When using Ezra, it helps a lot to look at the help text, and you're going to have to create your own little manual from all of it. There's a lot of parameters that it has, and I haven't even learned all of the parameters. I am by no means an expert, but Ted Klein is a great person to send questions to, because he will help you solve any issues that you have. Now, I noticed you mentioned you were taking 4,096 bins. How are you doing that?
Let's see, so I've done that in SDR Sharp with the IF average. You can do that. And then I've actually, more recently, I've been using the GNU Radio.
Yeah, okay.
Yep.
Which SDR is that you're using?
Well, I started off using the AirSpy R2, not the Mini, but the R2, and it worked really well, but I was having kind of a major problem with a spur. There's a spur line that was occurring, a stray line from the amplifier itself that was occurring like right in the middle of the hydrogen spectrum. And no matter what I did, I couldn't get rid of that. And it was definitely not coming from like actual RFI, it was coming from the amplifier itself. And this apparently is the AirSpy has a spur that shows up about every 100 megahertz, as I recall. It's very regular. So recently I switched over to using the SDR Play, the RSP R2 is what I'm using now. That's a little less sensitive. Somebody mentioned the AirSpys are really sensitive. So I do notice that the RSP is not as sensitive as the AirSpy, but I just make up for that by just increasing the gain a little bit. And recently I've put in a second little amplifier that I bought from Mini Circuits, another 20 dB amplifier that I just put in there, and that seems to fix it. I do think the signal to noise is not quite as good using the SDR Play, but it doesn't have any of these spurs that I was encountering with the AirSpy.
Yeah, I believe that Ezra effectively removes those central spikes during its processing. So anybody using Ezra doesn't really face that issue. And there's not an uncommon issue with many even quite expensive devices. I think my B210, if I remember rightly, tends to shoot up one of those in the center sometimes. So, but obviously it needs to be taken into consideration during the processing. So, when you say use medium,
this is different from the center spike, though, right?
See, okay, it's not the center spike we're talking about.
In most of these radios, you get a center spike from the DC offset.
All right.
That you can get rid of just by shifting the frequency response. Just by shifting the range of spectra you're recording, you just shift your spectrum away from that center burst a little bit. But what I was seeing with the AirSpy was it was moving. If I shifted the frequency range, it was staying at an actual fixed frequency, not necessarily in the center of the range. And that was just very difficult to really get rid of completely.
Oh, right. I don't know about that. Is that something that you've seen on your AirSpy, Andrew?
I have AirSpy R2 as well as the Minis, and I haven't seen those sort of effects. Yes, you sometimes get the center speak with the AirSpy R2. Definitely don't get it with the Minis, but I haven't seen the extra spurious ones.
Oh, I wonder what that is then. That would be worth putting on the SARA mailing list and asking about, definitely.
Yeah, I have absolutely no center spike with the R2, but I do have a spur that moves at exactly 1420.0 megahertz.
All right. So, Bob, you mentioned median filtering. So, how do you achieve that?
So I'm doing most of my processing myself in Python. So I just have a Python script that reads it in, and then there's built-in Python libraries for doing median filtering.
Right, so this is software you've written yourself.
Yeah.
All right, so that rules out most of us. Are these scripts that you'd be prepared to share with the group if anyone was interested?
Maybe at some point when I refine them a little bit more.
Okay, fair enough.
I am what I would call a hacker. I write things until I can get them to work, but they're not pretty.
Right.
So maybe once I get a little more experience and get this refined, I'd be happy to share them.
Okay. So, so I'm just going to pop back to Conrad, because I realise, Conrad, that you've been kind enough to share your data collection there, but what we haven't seen is any of your data. Do you have any data that you can show us?
Okay, let's see. Hang on just a second. The answer is yes.
And while Conrad's putting his data up there, Bob, do you have any of your data that you're able to show us after, perhaps when Conrad's finished? I mean, don't feel it. I would say don't feel any obligation at all. And if we will go through it, I'm going to go through everybody one after, but please don't feel anybody frightened. I've got to have something to speak to Andrew about and the group. This is only if you feel like speaking about something. So feel free to say not tonight, or if you want to, but. But I'll come to you next then, Bob, if you have anything that you want to show us. But let's let Conrad have a chance to show his data first.
Sure.
Okay, can everybody see that?
Now, I have a question to ask you about this, which is how on earth have you managed to get so much of 0 to 90? Because most of us can't get quite as much as that in our maps.
One advantage is I live on top of a hill. Okay. So,
and what's your latitude?
Let me see. I'm at 41 degrees latitude.
Maybe that's it.
I live on top of a hill, but I do have trees in the horizon, so I can go down to about 25 degrees above the horizon. That's about the lowest I can go. And then, of course, I can go all the way around. This was my first attempt when I first got the scope in the box. And I didn't have a lot of experience, but I was patient. And I would only do it during the day. I realized if you want to gather a lot of data about the other quadrants, you have to let it run 24 hours a day. But I was pretty pleased with this first attempt. As you can see, I've added a few labels onto this. We've got the sun that's right here, and this is all done using Ezra. They make it very easy. This is the galaxy center, and I was binning at a rate of 256. Okay, and so here is one arm of our Milky Way galaxy, and you can see a little bit of some of the other arms. So this is not bad for a first attempt, but I'm far from done, because right now I'm letting it run 24 hours a day, and I am getting some data in the other quadrants. I'm not done yet. Let's see. But I'll just leave it like this. And you can see with a little bit closer, you can see a little bit of data going into the inner arms. But, I was very pleased with this as a first attempt using just the scope in the box. I think a lot of amateur astronomers, once I've used this for a couple years, you got to build a bigger telescope. It's very, very interesting. Are there any questions that people have?
Have you considered replotting some of this data in 3D?
I did try doing that, and I found that the program Why, I don't know. It was very, very slow and would just hang up on me. I do have a good computer with an Intel iCore 7 chip, but it would be just way too slow. I don't know if I need to get more memory for it or what. I would love to do this in 3D, but I just can't. I haven't been successful with it.
Right. Okay. Well, perhaps you and I could meet up outside this meeting at some point if you're interested. We could have a Zoom together, and I could walk you through it.
Oh, well, that sounds good.
Yeah.
I know there is a parameter for the 3D version that you can adjust to get more memory.
Right. Well, it's just rather that in Ezra, Ted's got the option to produce the data files in a format that can be read by Rinnen 3D, and then that allows you to start
that's the one I've
plotting
been
it that way.
using. So I'm going to stop sharing and let other people jump in.
Yeah. I might in fact be able, if anyone, by all means talk anybody, but I'm going to just pull up a slide and just show you what you can produce. All of this has been done with a 1 meter size dish. In fact, it's been done with an 86 centimeter X. Oh dear, 86 centimeter X military array. Current slide. So that was my map. But you can see the limitation of what where I could actually get to on that. But you could pick up an outside arm very easily. That data just shows, and your data should be able to show this. That's sort of dark matter, or the smoking gun for it. You know, that's Keplerian, and that's clearly non-Keplerian there. And I hope you can see these graphs, these plots appearing on your screen. Please, somebody shout out if you can't. That's weighing the Milky Way. And these are some 3D images, which is what I wanted to show you. So these are slices through the same Milky Way arm there, and you can see an outside arm. So you should be able to again get this off your data. Again, that same arm from a different direction, various other ones. And then that's actually allowed me to pick up 2 further inner arms on the same data which weren't obvious on the 2D plots. Well, that's just my mini PCs. Okay, so I would encourage you to keep going with that, and you should be able to produce some plots like that without needing a bigger telescope. Okay, so anybody else like to comment at all on Conrad's discussion there? No. So yep, Karen.
Andy, I could chip in with something if you wish.
Chip in.
Yeah, okay. So this is relevant to Conrad's comment about bin quantities. So I've been doing a sweep. I did a sweep last year with the standard 256, and I've been re-sweeping again. I'm still working on it right now, but I've increased it from 256 is 8-bit, so I've increased to 10-bit, which is 1024. And I can show you a couple of comparative slides, some results. So I'll share the screen. I shall get the right one. Screen one, I think.
Just to say, I haven't forgotten you, Bob. So after Dave here, I'll come back to you.
Okay.
Yeah, no, it's fine.
I'll try and be as quick as I can.
No, it's fine. No, you take your time. Take your time.
Okay. All right. So let's see. So this is Ezra, okay, and these are the spectral cascades.
At the moment, on your screen, we can just see 9 of us staring back at us. Oh, here's your Ezra coming up now. Yeah.
Right. So that's an 8-bit spectral cascade. Let's see. Let's just don't want to make that too big. Let's just put that there. So that's 8-bit. Okay. Now I'm going to show you 10-bit.
Oh wow.
Now, I say this is not entirely apples for apples because this one's, I've also enlarged my dish from 1.5 metres to 1.9. And this is also aggregated over 40, each one's aggregated over 48 hours. But I did do a little presentation a month or two ago where I showed the results of these I separated it all out, and the bulk of it comes from the 10-bit. But you can look at the difference in quality. So, you know, yeah, I just wanted to show that because I know Conrad was talking about what happens if you go to 2024 and maybe even beyond, I don't know. But in my view, it's definitely worth doing. You know, look at that.
It looks brilliant.
So,
how were you able to decide that that was mainly due to going from 8-bit to 10-bit?
Okay,
rather than due to the increase in size of the dish.
Yeah, so I did a presentation on this 2 or 3 months ago, and I split it up. So I had one particular declination, and I showed flip-flopping between 8-bit and 10-bit, flip-flopping between 1.5 and 1.9, and flip-flopping between 24 and 48 hours. And the difference between 1.5 and 1.9, to my disappointment, because I spent bloody ages making this 1.9 dish, it was very small difference. The 48 hours to 24, that made a bit of a difference, but the big difference in isolation was 10-bit to 8-bit.
Okay.
Now, I don't have the equivalents for those individual ones.
Sure.
Maybe I should show that. So what you're seeing here is an aggregate of all.
So this is the number of bins that you're talking about.
Yeah, that's right.
In the
exactly,
FFT, and 8-bit to 10-bit, is that 256 to 512? Is that what you're talking about? Yeah. Yeah,
that's right. So if I just split out the 10-bit, 8-bit, it wouldn't be quite as good as this, but it wouldn't be far off. That's my point.
Yeah, sure.
So yeah, I think that's all. I've got some other things to talk about later, but just to chip in on what Conrad was talking about, I thought that might be of interest.
Brilliant. So I'll come back to you a bit later then. Thank you very much indeed.
Okay.
Thank you. Okay, over to Bob then. Bob, sorry to keep you waiting there.
Oh, sure, no problem. Let's see, how do I share my screen here?
So at the top you've got leave, share, and then just click on the share button, and you've got a choice. You can either click the whole screen or try individual windows. It's worth saying you don't need to learn too much about how to use this program, because from next month we're going to Zoom.
Okay. Oops.
Andrew, when you've got a moment, you see I put something in the chat.
I'm having a look now. Yeah, Tony. So, as mentioned earlier, the about AirSpy performance. 11 years ago, I sent a comparison of the AirSpy and FunCube dongle at H-Line. The FunCube dongle in narrow bandwidth mode was considerably better than the AirSpy. I have figures, and that was in BAA RA Magazine. Sorry. So when Bob's finished there, Tony, can I come to you and perhaps ask for a bit more information on that? And if you have those figures available, are you able to show them to us?
Yes, if you let me share my screen, then I can show you what I presented.
Of course, yeah. So after Bob's finished, we'll come to yourself.
Why don't you go to somebody else next? I have to change some privacy settings here in order to be able to share my screen.
Well, how about yourself then, Tony? Are you able to pull that data up now?
Yeah, it's on another screen. If I can scroll across, if I can share. How do I share?
Right, so at the top you've got leave in like a red put your phone down icon, and then just to the left of it is share. And then you can either choose the whole screen, which is whatever appears on your screen, or which I tend to go for because it's just easier, or alternatively you can try sharing a window, which is where you find you inevitably share the wrong window unless you're very clever.
I want to scroll across and find the screen. Can you see this screen?
At the moment you're not sharing anything.
Oh.
So you'd have to go to the share button next to leave, and then click on it, and then choose either screen or one of the windows.
Ah, right, okay. I'm sharing a window. or even an entire screen.
Yeah, if your entire screen is whatever appears on your computer, on your main screen.
So have you got anything yet?
Not yet.
No.
Does it say on yours that it's sharing?
Entire screen, open system. I think it needs permission, I think.
Oh.
This is a Mac, so it doesn't like anything to do with Windows.
Oh, I don't know anything. Anybody else know anything about Macs here at all? Lots of nods in the wrong direction.
I'm also using a Mac, and I think he's having the same problem I am.
All right. While you guys are looking, I just say that Richard has put a comment to say, very little to report here. My studies finish at the end of May and hope to start radio telescope construction then. I've bought a lovely table pillar drill in preparation. well done, Richard. So we can expect amazing things from you. I hope. Best of luck. Me, I just use an electric saw and an electric drill and bash away left, right and centre. And hope it works. Okay, so while Tony's looking at that, perhaps he's still looking at his, and Bob's still looking at his. We've got two people in. Oh, dearie me. Dave, shall I come to you in the meantime? Dave Bracey. Anything more you'd like to talk about, Dave?
Yes, of course. I'll just.
Tis all yours.
Okay.
And I'll go back to the other two guys in a bit when they've had time to look at things.
Okay. There we go. You can see me now. All right. Yeah, not too much. I just, as I was saying, I've been working on this re-sweep of the sky, trying to do a full sweep of the northern sky, sort of along the lines of what Edward's been doing, but he's got a much bigger dish than me. But anyway, I've been working on that. As it obviously takes quite a long time, but I've been progressively working my way down in 2.5 degree increments in elevation, and so I'm now down at 37.5 degrees, something like that. But one thing I have noticed, that the lower I'm going, I'm getting more and more RFI issues cropping up. So I wouldn't say battling with them, but I've been trying to learn how to deal with it in order to get the RFI out, in order to clean my plots up. So I'm doing 48 each of my elevations. I do 48 hours. So, and the RFI that comes along seems to be in blocks of 20 minutes, half an hour, something like that. So if I chop, let's say there's half an hour trouble, if I chop that out, it's okay, because if the current next day was okay at that time, it just the gap gets filled in. But the question is, when I'm faced with, I do an Ezra in Easy Con and it's all gone to pieces, where is the RFI happening? And I've been playing around with ways. I'm sure you guys probably know how to do this much better than I do, but I've been playing around with methods for doing this. I'll just share my screen again. So okay, let's set on screen one. Let's allow that. Okay, so let's bring up a picture. Okay, so I've been faffing about. So hopefully you're seeing that.
Yes, we are.
Yeah, everyone's seeing that?
We are, yeah.
So this is one of the Ezra plots. This is EastCon 98, and you can see here. Yeah, it all goes not too bad down here, and then it all goes a bit to pieces in the middle here. And I was using this to give me a clue as to where are the bits I need to chop out, and this was sort of useful. There's another plot here, Again, I'm showing an extreme case, by the way, here, where it's all very easy to see. Here's another one where it's the same time as the one I showed you before, where you can see this sudden uptick here where it all goes to pieces. And yeah, here's another one. So where you can see the trouble around here. So this was quite easy. All I needed to do was to go into the data file, look at the times when this is happening, chop it out, and then rerun EasyCon and see if it's fixed it. And if it's a bad case like this, then yeah, it often fixes it. And I was going to do a little sort of presentation on this to show how I was doing this at this meeting. However, the last one I did all this chopping and it didn't fix it. The way I did fix it was just by going through the days, finding the day where the 24 hours where the trouble was, then just manually going through the data file and first of all chop it in half. Is the trouble in the first half of the data or the second half of the data, and then gradually narrowing it down, and then once I've got to hour by hour, and then once I've got it approximately right, putting pieces back in until I build it up again. It takes a long time to do that, but it works. At the end of all of that, I've got some usable data that's I'm reasonably happy with. You guys probably know much better ways of doing it than this. I looked at the EasyCon study, but that didn't seem to help me really. The only way I've been doing it is just going in and chopping bits out and seeing what happens and trying to do it systematically to narrow down where the trouble is, and also using plots like EasyCon 18. So yeah, and doing all of that, it's practical and it's working. I suspect that my RFI is getting, you would expect it to get worse than with the lower elevations, I suppose, because you're just seeing more of the area, close to the ground where trouble is happening. But nevertheless, it's been doable, but just more hard work. And I'm sure all you guys are all well experienced at doing this, but for me, it's been a little bit. It's been worth. Been an education, shall we say, to learning how to do it. I've got a suspicion too that I think this is maybe contrary to what Conrad's saying. I've got a suspicion that 10-bit is worse than 8-bit at picking up RFI. Probably because when I was doing the 8-bit, I was averaging over much longer periods of time. Whereas at 10-bit, I've got smaller blocks, and so I don't know, maybe it's averaging over less time. Let's say maybe it's getting more trouble. But if the RFI is going on for half an hour, then it shouldn't make a difference, should it? But anyway, I just thought I'd mention that. There's some issues with RFI, so I'm sure we all have.
Well, you've actually reassured me, because I get the same problem, especially down towards the horizon, it might be something to do with the neighbour's house that's there, plus the large number of trees that stick up. So, and certainly trees can be quite bad in terms of causing problems with hydrogen line studies. So
I've been trying to work out what it is, because it comes in very suddenly. One minute it's there. It's not. 1 minute everything's fine, and then for the next 20 minutes it's all gone to pieces. And then it suddenly switches off again. So it's something switching on and off. And I've been going around the house trying to see if it's me that's doing it. That failed. I mean, maybe it's a neighbour. And the time, it's never consistent times either.
Yeah.
Always in the day, not the night.
I mean, I know there are people who have used LCD monitors or computer monitors as an actual source of 1420 megahertz emission to use as a signal source for testing hydrogen line scopes. They're that bad. The other thing which I know has been mentioned on the SARA forum quite a bit, apart from solar panel inverters, is actually any air source heating systems that you've got hanging around apparently can be terrible.
Okay. Yeah.
These aren't from personal experience. I've got to point out I don't have anybody around here with an air source heater, so although I nearly put one in a couple of years ago myself, so I'm pretty glad I didn't now.
I've been peering around, looking at people's roofs and trying to squint over fences and things, trying to see what it is, but failed so far. But anyway, whatever. It's still manageable at the moment.
You could get into the electricity cable and just disconnect it for the entire street for one evening, and then just do a test and see whether everything gets better.
Yeah. Need to chop it down house by house, don't I, to narrow it down. But yeah, anyway, there we go.
The other thing I would reassure you about, having spoken to Ted quite a bit about this, is that your mechanism for trying to find where the signal is in your data is the same one that he uses.
Oh, okay. Oh, that's good. That's reassuring. I'm sure I must be missing a trick. And you were going to say, you should just.
Well, there is the ability to top and tail the data, which can often work quite well. So you get rid of quite a bit of RFI by just chopping and tailing off very high amounts of. RFIs often peaks up at a very high level, so if it's higher than the highest level of your data, then you can remove all those signals by saying any signal that comes in, I don't know, greater than 100 or whatever it is, just chop it out of the data completely, and it will do that for you automatically.
And a lot of Ted's plots do show it often, but I was really triumphant. I thought, I'm going to present this and show this method, and then the last one I did, it wasn't like that. I had to take bits out. It was really bad, and I had to take bits out that just didn't appear to be fine. Couldn't see anything wrong with them, but took them out, and suddenly everything's great. So, don't know.
The other thing that I shouldn't admit on an open video like this is it's quite handy to have done a bit of astrophotography and learnt a few photoshopping techniques. Sorry, I shouldn't say things like that.
I'll try and steer clear of that.
As we were discussing earlier, though, have you tried adjusting the angle of the feed?
Was that you, Ted? Explain a little bit more.
Is your feed vertical or horizontal or somewhere in between? Can you twist the whole antenna around to adjust the angle of the feed?
All right, so this is getting back to the conversation, again to remind people watching the video, that we had earlier on in the video, which was to say that although that hydrogen line data wasn't polarized, so it wouldn't matter which direction your monopole was or dipole was facing, nevertheless RFI may well be polarized, and therefore if you could change the direction of that monopole, then you might get some benefit. It's first I've heard of that particular one, but it may be a good technique.
Worth a try, I suppose. I suppose the fact it's noisy sort of implies it's uncontrolled, doesn't it? So I don't know. Anyway, yeah, maybe worth a go, I suppose.
I don't know. The noise is some of the noise is because of the processing that's going on. It's not really at that frequency. It's just being picked up. It's probably very high intensity. It's squelching through the filters and so on.
Okay. It's not someone with a spark generator somewhere, but yeah.
Well, it might be. I mean, there's one particular thing I would recommend that's worth perhaps all of us thinking about, and I know Alex Pettit has mentioned this to me a number of times in Sarah, and that's about ground spillover. So basically noise that's bouncing off the ground, the trees and everywhere else. And in his experience, one of the most useful things to do is to extend the side of your dish by about a foot. And you don't need to bother to be parabolic, just a flat piece of sort of chicken mesh would do the trick all the way around. And it strikes me that would be a worse problem. Sorry, we got some feedback here. I'm just going to press mute, and then so do unmute yourself if you're speaking again. So that would be a worse problem if you were pointing further towards the horizon, I would have thought.
Dave's done that, hasn't he? haven't you, Dave?
Well, I have enlarged it. Yes, I have. But although it is parabolic, so I think what Alex was talking about was something. I think what he was talking about was something with a much steeper wall around the outside. So because my extension's parabolic, it means that my extensions are still picking stuff up. They're not blocking anything by design. So I'm not just selecting the middle bit. I'm selecting everything.
There's something I wanted to ask. Has anybody tried the loop feed that Alex Pettit puts in some of his antennae?
Sorry, who's that speaking at the moment?
It's Ted.
Oh, Ted. Sorry, Ted.
Yeah. Yeah, some of Alex's recipes for making yourself a folding dish, and he has a pie dish, but he has a loop feed inside it, so it's not polarized at all, and it's looped from the core to the shield. I've got it up on my screen if I share it for a moment.
Oh, that's a good idea. I was just trying to find it on mine. So you share yours, yeah, by all means, so people know what you're talking about. While you're looking for that, has anybody else had a go using a loop feed? It's not something I've tried yet, but it is something I'm hoping to try. They are supposed to perform quite well. Ah, brilliant.
And come up, yeah, so it's a loop of wire. The connector is off center, but the wire is in the center of this dish. It's a very shallow dish, which is not what we're all using. But obviously nobody's tried it, and I think it's quite interesting. You know, he's got his filter right on the connector.
Yeah, that was something I tested a year or so ago. It does make an enormous difference to have your filter just behind the feed.
Oh, I see, yeah. Yeah, anyway, I thought it was interesting.
Yeah. Yeah, well, certainly, as soon as anybody's had a go at that, please do come and discuss it on this forum so we can see how you got on with it. Okay, well, thank you very much, Dave. Anything else you'd like to talk about, Dave?
No, I'm still constructing my horn. It's I've had to stiffen it. It's much too floppy to construct.
Okay. Right. Okay, moving back to Bob. How are you doing now, Bob? Are you able to share your screen, do you think, yet?
I may be able to share mine.
Who was that? Tony. Okay, perhaps
Yep.
go with Tony then.
Are you the other Mac user?
I am, yes.
How did you fix the privacy things? Because it seems to me like I'm not able to find it.
I had to go to the Mac, what's it called? The settings, and it told me because I'm using the Chrome version of the the Chrome browser with the Teams. It told me I had to go to Chrome and tell it to be able to share a screen. Now I don't yet know whether it's working. I'm about to find out whether I've actually done it properly. So I'm just going to try sharing, and then I can share a screen.
It sounds like Tony and Bob, we need the two of you to run a special radio astronomy for Mac users forum.
Can anybody see that screen now?
Yes, we can. Absolutely.
With AirSpy at the top. Okay, good.
Yeah.
So that was setting up the permissions in Mac to do it. Anyway, this is something this is very boring compared with all the lovely stuff you're showing, but it was in the very early days of the AirSpy, which was a rather nice little unit compared with the FunCube dongle, which I'd been using for some time. And it was just that I tried comparing the signal to noise ratio as approximately hydrogen line. What I'd actually had was a GPS sort of dongle put on the windowsill and found a signal at, in this case, 1537 megahertz, which was obviously producing some frequency shift keyed stuff, and that was with the FunCube dongle, and then I compared it with the AirSpy. You can see the peak is a bit lower, but more importantly, I was looking. This was all in narrow band mode, so in terms of the hydrogen line stuff you're doing nowadays, it would have, the frequency would have to be swept rather than getting the whole lot in one go. So I was using the lower sample ratio for the FunCube dongle, and this was giving me 17.5 dB signal to noise ratio on this particular signal. And the equivalent with the same antenna plugged in was only giving me 7.5 dB signal to noise ratio with the AirSpy. So it was a full 10 dB better on the old FunCube dongle that Howard had all lovingly soldered together in his kitchen, but probably most of you won't remember about the FunCube dongle and how it arrived on the scene. Anyway, that was all I wanted to show. Great signal to noise ratio on the FunCube dongle compared with a rather worse signal on the AirSpy. That's it, really.
So what is the bandwidth on the FunCube dongle?
In this particular case, I was running it at only at 96,000 samples per second, so it would have had a 48 kilohertz bandwidth.
Mm-hmm.
So rather than the full width that you do when you're doing H-line, it would have had to be swept in frequency to get this better signal to noise ratio.
Right.
But I also said in this particular article that perhaps with the with the usual low noise amplifiers used for H-line astronomy, this will probably be okay. So anyway, it was just a little test of two different SDRs.
Yeah, I mean, I still use one of those to do my meteor observing on graves.
Yeah, and of course it's ideal for that.
Yeah, quite successfully. And are you doing any hydrogen line at the moment, Tony?
No, I haven't got there yet. Too busy rebuilding this computer at the National Museum of Computing.
Yeah, you should use that to do hydrogen line. That would be interesting. You find all the results coming out on cards. Try and feed them into Ezra and see what would come out the end of it. Yeah.
Well, of course, as you may remember, the national this EDSAT computer was actually used to analyse the data that was coming from that Cambridge telescope where they discovered the first pulsar and things like that. So it's not, but you know that was months and months of calculations to get somebody a Nobel Prize.
Yeah. I mean, talking of which, towards the beginning of this meeting, I'd asked Andrew what the potential advantage of an AirSpy over an RTL SDR was, and he didn't mention anything about the clock, which for hydrogen line is probably quite appropriate, as it probably doesn't really matter too much. But if you're trying to do pulsar observing, then it's very important that you've got an extremely accurate clock on the device, isn't it? And so the B210 and also the AirSpy have pretty good clocks on them, whereas the RTL SDR would probably not be the ideal device to try and start measuring pulsars with.
Well, that's one of the advantages of the AirSpy. It has got an external 10 megahertz input to lock the oscillator to an external reference.
Yeah, yeah. So that's for a different group. For anybody who wants to do pulsars, I think only Andrew's the only one who's got a big enough dish to be able to do it potentially around here. So is that something you've ever tried, Andrew, doing pulsars with your 4-meter dish?
It's something we're aiming for. That's why we're trying to improve the signal to noise.
Ah, right. So watch this space. So Bob, have you managed to be able to get permissions, or was that for another day? Was he gone? Seem to have lost him.
Let's see. I think I'm sharing my screen now.
Oh, yes, you are. Indeed, you are.
Okay.
Well done. Well done.
Excellent. Yeah, I tried like a whole bunch of different things. I gotta close some extra windows here. Let's see. Okay, so what I'm using is I built this horn antenna. Hopefully you can see that.
Very nice. Very nice
Yep.
indeed. I'm hoping
So
to
it's
build
about
one
a
of those
meter.
myself.
Yeah, it's fun. You know, the 75th anniversary of the first observation of hydrogen 1 radio emission was just about 75 years ago, so it kind of motivated me to do this. So anyway, it's made from lightweight panels with aluminum foil on the inside, a waveguide down here, and then I have the new Elect Sawbird. I have a little mini circuits, extra 20 dB amplifier, and then now I'm using the SDIR play. So I've been able to get, I've been able to do 2D scans. So here's an example of a 2D scan I did. I think this was 60-degree elevation over 24 hours. And it looks pretty good, except down here, down around 1420, I have this problem of, it was originally, the problem was the spur. So here,
Oh, sorry.
This
Can
is what
I
I
just
was-
interrupt you just a second? I do apologise.
sure.
Royston,
Yeah.
I noticed that you just said you need to leave. Was there anything you quickly wanted to say before you went?
Yeah. No, I'm okay, Andrew. I'm here to learn a little bit, actually. I've got all the equipment on the way.
All right. Okay. So you haven't started yet.
No, I'm just doing the muons and media scatter at the moment. But I've ordered all the equipment from the crowdsourced people over there. So the Discovery dish is on the way in the air somewhere.
Wonderful. We're supposed to perform very well. If you need any help, give us a shout and we can set up a Zoom
I
meeting
will,
together.
Rich. I probably will need some help.
Yeah, brilliant. Well, lovely to speak to you, and I look
Okay.
forward to seeing you next time.
Okay, thank you very much.
Okay, all the best to you. Bye bye now. Yeah, yeah. Sorry about that. I noticed that you needed to
no,
go.
that's fine. No,
I've got to say, you've
absolutely fine.
got a lovely image there. Before you
Yeah,
continue,
so-
that horn that you've made, is that a horn of plenty, a SETI horn of plenty?
No, I mean, I basically designed it from scratch. I looked at some of the original papers on design of horns, and I just optimized it for that. I don't know how different it is from the Horn of Plenty. It's about 1 meter across,
Right.
so it's probably similar. And then I just built from extruded aluminum. I built this little frame, so it's basically aluminum angle with very lightweight corrugated polyethylene sheets bridging the 4 pieces of aluminum angle, and then aluminum foil on the inside going down to the waveguide section.
Mm-hmm.
And then I built this little frame. This 4 little segments here are extruded aluminum on a little pivot so that I can tilt it in one direction. I can't swing it in the other direction, but I can point it along the north or south meridian and tilt it to pretty much any angle up to about 85 degrees, and then this bottom begins to hit this crossbar. So this is what I've been working with. I'm in the process of making a dish antenna that will be just about 2 meters in diameter. I'd like to have something that's got a more directionality and higher gain than this has. But this is actually working quite well. I mean, I'm learning a ton. So with that, I've been able to make 24-hour scans and convert them into 3D plots and things. The difficulty I've had is around 1420. I mentioned the spur line. So let me show you. The spur line is at exactly, it would be 0.2048 on this graph. Sorry, this is a plotting program that I use a lot. Be 2048 point would be, well, it's probably this little peak right here. But it's sometimes very large. So here's an example of a set of scans I took, and here you can see this peak at exactly 1420 megahertz. It's huge, right? Here's my hydrogen signal right here, and like the previous speaker, I sometimes will randomly get this large amount of RFI that's shown by all these red peaks. So I was talking about, I mentioned the idea of taking a higher number of points during the Fourier transform and the benefit of that. So I was comparing some different software programs. So one of them is shown in red. This is the D-Spira program that comes out of the West Virginia group, where we have 4,096 points in the spectrum before doing the interferogram. There's another program that I was exploring using. There's a guy by the name of Ayushman, and I don't remember his last name, but he's been active in the online chat group. Wrote another program called HQuick that, for example, has 512 points. So I ran the exact same thing using both programs, like one right after another, just to see how they compared. And you can see that that's what's shown in blue. So this is the program using 512, and the red is the program using 4,096 bins. But the advantage of having the 4,096 bins is that each of these very intense peaks is exactly 1 pixel wide. And so even doing a very simple median filter, you can very effectively get rid of those. And that's what's shown in the green. Whereas the spectrum using 512 points effectively spreads that information out over a wider frequency range. And so it is actually more difficult to get rid of many of these noise peaks compared to the hydrogen signal. So if I blow this region up, in particular, like this big spur line at 1420 cleans up very easily just using a median filter. Whereas if that same peak was recorded with a wider frequency range, it would be essentially closer in width to the actual width of the hydrogen spectrum, and therefore much more difficult to get rid of. So this spur line was very annoying. I spent a lot of time trying to figure out how to get rid of it, like shielding and going through all these experiments of turning things on and off and going to battery operation and using a Raspberry Pi instead of a Windows computer and putting an optical isolator in the USB, and nothing that I did anything to this 1420 megahertz line. I could shift the center frequency and it would stay at exactly 1420. And I actually had a second Air Spy that I bought shortly after the first one, and it also had the same problem. It wasn't as bad, but if you read the documentation, they do say that there is this spur line that occurs every 200 megahertz. with the air spy. So because of that, I went over to the what's called the SDR Play RSP, and that one is not as sensitive. But let me just see here if I can pull this up. Actually, I'm running it right now. I can show you. This is the new radio running real time. So this is in my backyard right now. So right now I'm not anywhere close to the peak of when the Milky Way cuts through here. But you can see this peak is much cleaner, and there's no evidence now of a 1420 spur. There's a few little wiggles in the passband. It's a little hard to see on this scale, but if I blow this up, you can see that there's these little wiggles, but actually I found it very easy to get rid of these almost completely just by taking a calibration spectrum where I shift the center frequency and then either divide that out or subtract that out. So that's giving me much cleaner spectra. I still occasionally have this RFI interference up here, but it's in general pretty easy to get rid of these as long as I'm taking a large number of points in the interferogram. So that's pretty much what I'm up to, and I think the critical point in terms of making this work is this interleaved filter that gets you up to 4,096 data points for the Fourier transform. That really seems to help, in my experience, again, in terms of getting rid of all of this, and in terms of getting rid of all of this RFI. So what I'm doing now is I've been taking stands at different elevation angles, 10 degrees apart, because the horn doesn't have that great of a directionality to it. And I'm about 2/3 of the way through that. I'll probably have to move it to some other location because I can't get down below 40 degrees. And actually, when I start pointing toward 40 degrees, I'm pointing almost directly toward a television tower, and that just makes everything go crazy. So I have another location about 30 miles away that I can bring it to. So I'm doing that, and then also I'm building like I said, I'm building a dish, which will be just under 2 meters in size. What I'm hoping is that so I've done a lot of astrophotography, and I have 2 pretty heavy-duty equatorial mounts, and I'm trying to make the dish antenna light enough that I can fit it on the equatorial mount instead of my optical telescope, and then be able to track things and look for things like quasars and other things beyond the Milky Way.
Just be aware of the effect of wind on your dish. Tend to act a bit like a sail.
Yeah, I'm building a sparse aluminum frame, and then the rest of it will be aluminum window screening. So.
Yeah, but especially if you're trying to build a 2-meter dish, it might be an issue. Plus, you've got is it the moment, isn't it? It's how far something is away from the fulcrum and what effect that has. But I'm sure you know more about that than I do.
I'm sorry. How far it is away from what?
Well, you know, I mean, anything that you've got, I mean, it's distance away from the fulcrum effects. It's I forget the terminology from it. Long time since I did physics at school, but you know, it affects the effective force that's on the.
Oh, the lever arm. Oh, yeah.
Yeah, your leverage. That's right. Yeah.
Yeah, we'll see.
I know somebody's put up a message on the chat to say the electronics in your mount could introduce noise. I would just say that Eduard Moll from Sarah has very successfully used a HEQ Pro with a 1 meter mesh dish, actually a 1 meter solid dish, to actually detect. I I think it's hydroxyl quasars at 22 gigahertz. So it definitely can be done. Definitely can be done.
Yeah, the mount I have is a pretty heavy duty one. It's rated at a 70-pound capacity. So we'll give it a try anyway.
Yeah, well, it should be a lot better than the HEQ 5 Pro then. So yeah, I should think it'll do. I'd be very interested to hear what you come up with. That to be brilliant.
Yeah.
Yeah, fantastic.
Yeah,
Fantastic.
and then most of the processing I'm doing in Python, and then yeah.
Wonderful, wonderful. Okay, has anybody got any comments they'd like to ask Bob, or any questions to ask him, or any comments to make?
Good evening, everyone.
Hi, Francesco.
I would ask to Bob. He spoken about AirSpy R2 connected with Ezra. I would ask him which DLL he used, because Ezra uses the RTL SDR DLL.
See, I'm not using Ezra. I've never used Ezra. I was using SDR Sharp with the IF average plugin. And I also use New Radio. They both use the Osmocom. It's the Osmocom DLL.
I understand. I think you was using Ezra with AirSpy R2.
I'll have to try Ezra sometime. Maybe I should try that. I mean, one thing I'd like to do is right now I'm using a Windows 11 laptop to do everything, and I had experimented with the SDR Sharp. With the AirSpy. I also was using a Raspberry Pi quite successfully. I don't know that I can get the Raspberry Pi to work with this particular New Radio setup. I have to maybe figure that out. Right now I'm just doing everything with the laptop, but I really would like to move to the Raspberry Pi and not tie up my laptop 24 hours a day, 7 days a week, taking data.
I would use a mini PC, an Intel i5, to collect data, not the master PC of my station.
An i5, okay. Yeah, I use a mini PC actually for my astrophotography work. So that's actually another advantage. If I move it onto my equatorial mount, I have a mini PC right on there that I could use. Yeah, I should try that.
Yes, they cost not much. They are cheap.
Yeah.
Use it second hand. You can find very easily second hand.
Yep.
Thank you.
So Andrew's pointed out that Despera have Raspberry Pi installers for anybody who's considering using Raspberry Pis.
Oh, okay.
Any other comments, Robert, here? No. Well, thank you very much indeed. That was really interesting. Really appreciated. So it's fantastic. Thank you. So, Francesco, it's lovely to see you this evening. And how are you getting on with your projects at the moment?
I'm trying to mount the mesh, the aluminium window mesh against the mosquitoes. I'm waiting to build the feeder.
Mm-hmm.
I think to use a antenna because I'm skeptical because the feeder should have a diameter of 16 centimeter and the length of about 13 centimeter, but not not 30 centimeters, sorry. But the problem is not the length, but it's the diameter of the can. I try. At the moment I have an 120 centimeter dish. Is finished. It lacks at the moment only as I said, the mesh, the aluminium mesh, and the problem is at the moment how to fix it to the frame of the dish. But I will find a way.
Yes, I think that's often a problem. How are you going to do that? I've also bought a bit of mesh to try and extend my dish around the edge, and I haven't yet worked that one out myself yet. Has anybody else got any suggestions of the best way to fix a bit of mesh to extend the edge of your dish to reduce ground spill? No, it looks.
Andrew, I have a question. So I don't
Yeah.
I don't have an answer to your question, but to minimize this ground effect, what you're proposing is putting some extra mesh that I'm trying to understand what is the orientation of the mesh that you're talking about in order to reduce the ground effect. Is it just like almost a parallel tube now, which is extending out a little bit beyond the dish, but it's not tapered, so it's not reflecting anything back up into the receiver area?
Yeah. So this idea of using some extra mesh, or, for want of a better term, or any other sort of Faraday fabric or anything else like that around the edge of the dish, has come from Alex Pettit, who is pretty much acknowledged as the antenna expert in SARA, and has done a number of tests on these things. And so I'm just quoting what I understand from him rather than anything to do with my own expertise. Okay. So and things that he's told me. So he is not proposing that people need to try and extend the parabola to try and get a better reflective area back to the focus point. This is literally just a device to reduce signals from bouncing off the ground, trees, etc., and causing interference with the signal that goes to the focal point. So it's just so it can be flat mesh or whatever else that you're using, and it just extends out around, for a 1 meter dish, around about 30 centimeters around the edge of the dish. And in his tests it seems to have been very effective, but again I must emphasize this is nothing that I have done myself. I am just quoting what he has told me, but knowing Alex, they were probably very well done tests, and he's probably got a lot of evidence. But in fact I know he's presented plots to demonstrate an improvement on this.
Okay, thank you.
Yeah, and I don't think it really matters what you use, to be honest. We're talking about mesh, but I think he started off using Faraday fabric, if I remember rightly. The mesh is just less prone to wind and easier to. I think he's ended up with mosquito mesh, same as Francesco's talking about. Sort of screen mesh for doors, I think, sold in the States. But how it's connected to the side of the dish, I do not know. I suppose it depends on your dish, really. The other thing he does, just worth pointing out, is he puts some of this same mesh. If you've got a mesh dish, such as the one that's sold by Newelec, or a Wi-Fi dish, which is just composed of sort of aluminium slats with holes between them, then he actually puts some of this same sort of mesh behind those slats. And I know there was some logic, again, this is where my lack of understanding comes out, but some logic, just something to do with, although in theory the slats on these mesh dishes shouldn't make any issue in terms of the direction between the slat, in the direction of the between the two slats, because you've only got like 1 to 2 centimeters, or say about a centimeter between them. But the problem is in the other direction along the slats, where you've got quite large gaps in that direction. But you might explain that better than me.
I think he's actually like, that's basically a polarized antenna, right? A wire grid like that is a polarizer. So the satellite emissions are polarized, so you can use a polarized dish. But for hydrogen, it should be unpolarized. So if you just put a mesh in back of the dish, then in principle you're converting it now into an unpolarized dish, and you're getting an extra factor of 2 because you're getting all the electric field that's in the other direction.
Yeah, that sounds logical to me, but as I say, it's beyond my level of expertise anyway. I don't know, does that make sense to you, Andrew? Would that be logical, you think?
Yeah, I mean, sort of. With extending the dish, I'm not sure that it matters what arrangement you put on the outside, because it's essentially similar to putting a choke on a feed horn or on a waveguide, that you're trying to avoid the spillover. And if you're not altering the feed point height, then it's just adding extensions, because hopefully the position of the feed horn shouldn't be illuminating the entire dish. It should be slightly less than the entire dish, but by extending it around the outside, you're increasing the protection from spillover.
Right. So that's having the same effect as reducing it down by using a choke on the waveguide. Okay.
Yeah.
Great. I know the other thing that he's talked about is using a deeper dish to achieve the same effect. And the problem with shallow dishes, so technically a shallow dish should be able to collect as much data, but the problem is it's also much more prone to spill over as well. So again, Alex is the type of person that does this with dish after dish after dish and tests them to come up with some data. Most of us tend to choose one thing and go with it, don't we? So, going back to how far you've got yourself, Francesco. So, what's your next steps now in terms of putting your kit together and starting to collect hydrogen line data?
My next step is if my actual dish of 120 centimeter works reasonably okay, I will increase its diameter to 1 meter and 80 centimeters, maintaining always the same focal length. This way, I should have a parabola with an FD ratio of 0.4 instead of 0.6.
Okay.
Of the 120 centimeter parabola, and meanwhile I also designing an horn antenna, because it's simpler than parabolic dish, and I obtained it on WR650 cable transition from hand connector to waveguide. This waveguide WR650 is specifically for the hydrogen line frequency. So these are my two different projects at the moment.
Okay. Okay. Well,
And now I'm trying to learn to use Ezra without antennas, only connecting my receiver.
mm-hmm.
I have the AirSpire R2. I'm ordered on the AirSpire Mini. I have RTL Block V4, V3 I'm waiting for. So I have many SDR receiver to test with Ezra and AirSpy, so the AirSpy software.
Sounds like you've got a good year ahead of you of work.
Thank you.
Are you actually buying your WR650 waveguide tubing?
Yes. No, I bought. It was a new stock, a new stock of transition. I found it on eBay from an electronic surplus reseller. I paid about 300 euros.
Okay. Yeah, when I tried to buy some here in the U.S., it was the cheapest I could get it for was like $800. So I ended up like for my radio horn, I have 10 inches of what is essentially WR650 at the end. And I made that by taking a large aluminum sheet and then bending it into a rectangle and then sealing up the seam, putting the seam along the broad face and then sealing that with adhesive aluminum tape. And that actually seems to work okay. But it would be nice if you could buy it at a reasonable price.
If you wait a moment, I try to show you this transition.
Yep.
You should try 3D printing it.
So remind us, Andrew. At the moment, are you still using the material that has got some? Is it copper impregnated in it? Is that right, or are you coating it with something on the outside?
Yeah, so it's copper silver spray paint that you paint it with. But what I found is that when you put that outside, the silver does oxidize.
Mm-hmm.
So I've then coated it again with a sort of plastic spray paint to protect it from the elements. But yeah, it works fine.
Right. Okay. So
Francesco, can I see that? Okay. Yeah, I heard him say. Yeah. Okay. Oh, so it's actually a waveguide to coax converter. Yeah. Okay.
So this is Captain band. I glue it for protection.
Yeah.
Because the inside of the cavity is silvered.
Okay.
Is about 1 kilo, I think.
Yeah, I'm sure.
Is a professional from manufacturer Selenia. Is an Italian producer of high-tech antennas and devices.
Nice. Write that down. I'll look them up.
indeed, wonderful. Thank you very much indeed, there, Francesco. Brilliant.
Thank you.
Okay, fantastic. So, Steve. So I think you're the last person. Certainly not the least by any means at all. But is there anything that you would like to talk about tonight?
No, not really. I'm just trying to gather information to figure out how to get started in doing all this.
Oh, you just scope in the box. If you have never done anything else and you're not sure what to do, if you have more expertise, then you can have a go at making it completely from scratch yourself, like some of these guys have done. But otherwise, you can't go wrong with scope in the box package.
I've been an amateur radio operator for 35 years or something like that now.
Oh, right.
So I've got a little bit of history, and that's my background's in electronics, specifically in radio electronics. So I've done quite a bit of work with that. A little bit lower in frequency. I think the highest frequency stuff I did as a professional is around 900 megahertz. But it's an interesting challenge and interesting part of the hobby that's been sitting there kind of stewing in my brain.
Well, in that case, you can build your own 5-meter dish and build your own cavity filter and probably build the SDR as well.
I've been trying to figure out how to design the parabolic reflector so that I can 3D print it. So yeah.
Oh wow! Oh gosh! So that would be really interesting to see when you come up with some plans for that. So please do share them with us here on this group. It would be really great to see to go through with you through the project as you take it from the beginning. Just the planning stage and maybe some of your prototypes to actually hopefully coming out with something at the end.
It would be a challenge for me. I retired about 1.5 years ago, so I've got spare time on my hands. So I do have time to mess with things and learn new things like 3D CAD. So it's going to be a challenge.
Yeah, well, I retired on health grounds last year, and I thought that would give me lots of time. But then my wife decided I needed to go to the gym for 2 classes every morning, so that's taken up a load of my time.
Yes, mine's been taken up primarily with doing visual astronomy, and I'm starting into astrophotography also.
Oh, well that's going to take up your time and an awful lot of your money as well, I should think.
It will. I'm sure it will. We have a public outreach here with our club, and I'm a team leader on that. So I had my first night actually Saturday night, and we had a very good crowd and beautiful clear skies. So we had a great night for it. So it was a great beginning of the season for us.
Where are you located?
Where are you located?
That was Rob was coming the same question.
Yeah, Kansas City.
Okay.
In the middle of the
I'm going
United
exactly
States.
the opposite direction. I've done a lot of astrophotography, and now moving into radio astronomy because we don't have enough clear nights here to.
I've had some questions about that lately. We've had 3 tornadoes probably within 20 miles of my house in the last 3 weeks. So I've been kind of concerned about it. But that's about where I stand at. I appreciate you letting me sit in here and listen.
Oh, you're extremely welcome. But please do, as you start doing things, please do share them with us. This is very much a group for people starting off and doing the journey, as well as people who are further along.
All right, I've got some materials to work on one of Andrew Pettit's Yagis. So, and I've got a Neolec SDR and the H1 amplifier, so I got a good start, I think.
Yeah, I
don't know about the software stuff.
Yeah, I've got one of Alex's Yagis as well. It is very good.
I was thinking about doing an array.
Oh, well, several of his Yagis. Oh gosh.
Yes, I was thinking about doing a 4-unit array. So I'll have to see how that works out.
Yeah, gosh, it'd be very interesting to see it. So thank you very much for sharing that, and lovely to see you this evening. Brilliant.
Good to be here. Thank you.
Right. So is there anything else that anybody would like to talk about that we've not had a chance to discuss? No? Well, brilliant. Well, look, guys, thank you very much indeed for being here and for all that you've discussed tonight. It has been extremely interesting and it's always great to see you every month. So the next meeting will be on the first Monday next month. And Edward Mull has offered to come and speak to us about his projects. For those of you who attend the SARA meetings, you will know that Eduard has actually made his own 3-meter dish recently, literally from scratch, and it does drift scans, and he uses that very successfully for a range of projects. So hopefully you'll be able to pick up some ideas from that you might find relevant to your own projects. But we're going to move over to Zoom, so I'll be sending out a Zoom link to you. So look forward to seeing you on Zoom next month. All the best to you, and have a great week.
Sounds good.
Okay,
Yep.
bye now.
Thank you.
Cheers. Bye.
Bye.